Assalamualaikum and hi everyone. We are from Group 2 and this is our video presentation for the course MAT 183. So for this presentation, our topic is technique of differentiation. We will go through a set of questions related to this topic, including understanding the meaning and technique of differentiation, solving problem using the product rule, chain rule and implicit differentiation, and applying linear approximation for estimating values. Each member of our group will explain one of the questions in detail, step by step. We hope this video help you understand the concept and application of differentiation more clearly. So let's meet our team member. Here we have Fakiha from program CE 112, Shanaz from program CE 112, Ain from program CEC 110, and lastly Amshar from program CE 112. So what is differentiation? Differentiation is a process of finding the derivative of a function which represents the instantaneous rate of change of the function with respect to its input variable. Essentially, it's about determining how much a function output change for a small change in its input. So here are a few techniques of differentiation. We have the product rule, the constant multiple rule, the sum rule, the difference rule, the product rule, and lastly, the quotient rule.
We move to the question 2. Let's look at the part A. We asked to differentiate the function y equals to x power of 3 sin 2x. Since we have a function we multiply x power of 3 and sin 2x, we apply a product rule. According to the product rule, dy over dx u v prime plus v u prime. For the u equal to x power of 3, u prime equals to 3x power of 2. And for the v, sin 2x, and we get v prime 2 cos 2x. Here we apply the chain rule because of the inner function 2x. Next, we just insert the differentiate to the product rule. Simplify the bracket. We move to the question B. Y equals to x minus 3 over exponent 2x plus 1. For this question, we use a quotient rule. For the quotient rule, we use a dy over dx equals to uv prime negative vu prime over v power of 2. For this question, the upper one for the u and the lower one for the v. U equals to x minus 3 and the u prime for the equals v to 1 is exponent 2x plus 1. V prime is just doing again with the chain rule applies. We get a 2 exponent 2x plus 1. The next step, substituting into the quotient rule. And that's the answer.
So for the next question, which is question number 3, the question is given y power of 3 plus 4x ln 2y minus exponent power of 2x plus 1 equal to exponent power of 2y plus sine power of 2x. find the dy dx using implicit differentiation. So the first thing we need to is differentiate both sides of the equation with respect to x, which is this. So we need to differentiate it first. When we differentiate y power of 3, we will get 3y power of 2 dy dx. Keep in mind that if you differentiate something involving with y, it needs to multiply with dy dx because we are differentiating y with respect to x. So for the next term, which is 4x ln 2y, we need to use the product rule since it's a product of two parts. So for this, we need to identify which one is u and which one for v. So for u, we get 4x. If we differentiate 4x, we will get 4. And for v, we get ln 2y. If we differentiate ln 2y, we will get 1 over y dy dx. So when we apply the product rule on it, we will get 4x over y dy dx plus 4 ln 2y. So for the next equation is exponent power of 2x plus 1. When we differentiate it, we will get 2 exponent power of 2x plus 1. So the next equation is exponent to power of y. If we differentiate exponent power of 2y, we will get 2 exponent 2y dy dx. Like I said, if we differentiate something involving with y, we need to multiply it with dy dx. So for the next term is sine power of 2x. For this one, we need to use chain rule. So we need to let u equal to sine x. So sine x equal to u power of 2. So if we differentiate u power of 2, we will get 2u, and if we differentiate sine x, we will get cos x. So when we apply the chain rule on it, we will get 2 sine x cos x. So here is the complete differentiate of the equation. I mean the equation that we already differentiate. So that the next thing is we need to rearrange all of this. The equation that have dy dx on it, we will put it on the left hand side, and who does not have dy dx, we will put in on the right hand side like this. We have so the left hand side we have 3y power of 2 dy dx plus 4x over y dy dx minus 2 exponent power of 2y dy dx. So the right hand side we get 2 sin x cos x plus 2 exponent 2 power of 2x plus 1 minus 4 ln 2y. After we rearrange all of these, like if we already arrange all of this, we need to factorize the dy dx because we need to dy dx let alone on the left hand side. This is what we get after we factorize it. After we factorize it, we need to bring this to the right hand side, which is we need to move them to this. So after we move this equation to right hand side, we will get dy over dx equal to 2 sin x cos x plus 2 exponent power of 2x plus 1 minus with 4 ln 2y over 3y power of 2 plus 4x over y minus 2 exponent 2y. So the final answer is here. We get 2 sin x cos x plus 2 exponent power of 2x plus 1 minus 4 ln 2y over 3y over 3y power of 2 plus 4x over y minus 2 exponent power of 2y. So here the final answer for the question 3, which is implicit differentiation. So yeah, we will go to the next question.
Hello, I'm Ain Khadija, and I will be explaining question 4, which is about linear approximation. So what is linear approximation? Linear approximation is a method for estimating the value of a function near a known point using the tangent line at the point. Let's say you have a function fx and you know its value and slope at a point A. The linear approximation of fx near x equals to a is fx equals to fa plus f prime a multiplied with delta x, or x equals to a. This formula is basically the equation of tangent line to the function at x equals to a. Now to answer question 4. Question 4 states, use linear approximation to estimate the value of 9.03 square root plus 1 over 9.03 square root correct to 3 decimal places. From the question, we know that fx is equal to 9.03 square root plus 1 over 9.03 square root. Since we need to differentiate fx, we will have to replace 9.03 with x. So now our fx is x square root plus 1 over x square root. Now, after getting fx, we need to convert from radical notation to exponential notation. Or we can also write it as x to the power of 1 over 2 plus 1 over x to the power of 1 over 2. Then we will write it as x to the power of 1 over 2 plus x to the power of negative 1 over 2. Now, to differentiate, we need to bring 1 over 2 to the front and it will become 1 over 2x. We have to subtract 1 over 2 with 1, so it will become negative 1 over 2. We will also do the same thing at the back, so it will become negative 1 over 2x to the power of negative 3 over 2. Now, once we have differentiate, we will get f prime x equals to 1 over 2 square root x minus 1 over 2 cube root x. Now that we have got f prime, we need to find delta x. So, in order to find delta x, we need to find x, which is the given value, and x0, which is the estimate value. From the equation, we have gotten x, which is our given value, is 9.03. Now, to find x0, which is the estimate value, we need to estimate the closest number to 9.03. So, I will use 9 as our estimate value. So, once we have gotten our x and x0, we will now find delta x. Delta x is equal to x minus the x0. So, therefore, we will replace x and x0 with the value that we have gotten, which is 9.03 minus 9. So, we will get 0.03 as our delta x. Okay, so back to the formula. Once we have gotten fx, f prime, and delta x, we can now substitute all of those into the formula back. So our fx is equal to x square root plus 1 over x square root. Our f prime is 1 over 2 x square root minus 1 over 2 cube root x, and delta x, which is 0.03. Now, based off the formula, we know that we need to use x0 as our x. So we have gotten our x0, which is 9. So therefore, we need to substitute all x in fx and f prime to 9. Now, we can finally substitute all x with 9. So, we will write down as, in bracket, 9 square root plus 1 over 9 square root, close bracket, plus, in bracket, 1 over 2, 9 square root minus 1 over 2, cube root 9, close bracket, multiply with 0.03. So our final answer wants in 3 decimal places. So therefore our final answer should be 3.331. And that's it. To make sure that our answer is close or almost the same from the equation, we can just calculate the equation from the calculator. So after I calculate it from the calculator, I will get 3.338. That is the end of question 4. Thank you for listening, and I hope you will understand our explanation well. Thank you.